Okay, last thing is finding the equations of your polygons and talking about least degree. These aren't so bad putting them in factored form, but you're going to have to watch out for things like when it asks you to put it in standard form. So what I would do with these is I would start out in factored form, which is pretty simple, and then multiply it out to do factored form. So for this first one, it's going to be, well, my root is at +4, so I know the factor is going to be at -4. This one's at -1. This is going to be at +1. One's going to be at negative radical 2, and the other one's going to be at positive radical 2. And all you do for these is you just pair them off, multiply it out, and then multiply them by each other. So for this first one, I'm just going to do 2 boxes because most of you are comfortable with a box. This is going to be x -4 by x + 1. My other box is going to be x minus radical 2 and x plus radical 2. X times x is x squared for this one. This is 1x. This is -4x, and this is -4. So for my first part, for my first product, after I multiply these two, I have x squared minus 3x minus 4. For my other one, this is going to be x squared. This is x radical 2. This is negative x radical 2. And this is going to be negative radical 4. Now, if you remember, radical 4 is actually equal to 2. So you're going to write this as a -2. So when I write my second product out, it's going to be x squared. These subtract out, -2. Okay? Then the last thing you do is you just do another box, hoping it left room. Okay? And so one side is going to be x squared minus 2. This is going to be x squared minus 3x minus 4. So I'm going to multiply this one out. It's going to be x squared times x squared, which is x to the 4th. X squared times -3x is going to be -3x cubed. This is going to be -4x squared, -2x squared, 6x, and +8. So when I write all of this out and make sure I combine my like terms, I have x to the 4th. I can't combine it with anything. I go next, I have a -2x squared here and a -4x, so that's going to be -6x, or no, sorry, before I do that, I have my x to the 4th, I have my -3x cubed, then I have my -4x squared and -2x squared, which is -6x squared, then I have my plain 6x, and I have my 8. And so there it is. There is my function f of x in standard form. All right, number 11, it's just a little bit of practice with imaginaries. Remember that if there's one imaginary root, there's another. So if +3i is a root, then -3i is a root. Okay, so I write this out. This is going to be x plus 4 times x minus 3i times x plus 3i. I do the same thing I did before. I'm going to pair these two off, though I always like to pair conjugates where it's like the same thing, but one is plus and the other one's minus. So I'm just going to multiply this out. Okay, x minus 3i, x plus 3i. So this is x squared, 3xi, -3xi, -9 times I squared. Okay, what you need to remember is I squared is equal to -1. So this box right here is going to be -9 times -1, which turns into +9. These zero each other out. So I still have my x plus 4 that I have to deal with. I haven't done anything with that left. But in these boxes, I have an x squared, and then I also have a +9. Okay, so I do a box for x plus 4 and x squared plus 9. So it's going to be x plus 4, x squared plus 9, so 4. This is going to be x cubed, 9x, 4, x squared, and 36. And all I have to do is write it out. So my function is equal to x cubed plus 4x squared plus 9x plus 36. All right, so that was that one. All right, last one, write the equation of the polynomial with least degree from the information given. First thing you do is we want to write the equation, so we have to find our zeros. This one has a 0 here with a multiplicity of 2 because it bounces. There's a 0 here, and we're going to say that this 0 is at 2. So my actual location of my zeros, I'm going to say this is about negative 3/2, so negative 1.5. This is about positive 1/2, and this one is at about, let's say, positive 2. Okay? Knowing this, so my multiplicity is going to be a little bit different. So my multiplicity for the first point is 2, this one is 1, and this one is 1. So I know that this is going to be 4th degree. Okay? And when I write it out, well, here are my zeros. My zeros are at negative 3/2, positive 1/2, and positive 2. So when I write this out, this is going to be, when I write it out, it's going to be, well, I'm dividing by 2, so I know the root is going to be multiplied by 2. And instead of minus 3, it's going to be plus 3. And that had a multiplicity of 2. This one is going to be 2x minus 1 and x minus 2. And so there's my function. Last one, again, I didn't mean to have all of these fractions. This is going to be about 3/2. This 0 is at 0, and that's at negative 3/2, and this is at about positive 3/2. Okay? Now we look at multiplicity. So the multiplicity of this one is 2. The multiplicity of the second one is 1, and the multiplicity of this one is 2. Okay? And so let's write this equation out. So my roots are at negative 3/2, at 0, and positive 3/2. So I rewrite this. This is going to be 2x plus 3, x minus 0, and 2x minus 3. We can rewrite this because we can simplify this. It's going to be x, 2x plus 3, 2x minus 3. But something that you notice, my multiplicity of both my 3/2 needs to be 2. What degree is this? There are a total of 5 zeros. So this is going to be, so my total degree is going to be 5. And that's what I have right here is my 5th degree. So hopefully I didn't confuse you too much. I apologize for the weird points. Don't worry about that too much on your test. And good luck.